In this video lecture, we will learn refraction of light. When light ray incident from one transparent medium to another transparent medium, then some of incident light gets reflected back in same medium and a remaining part enters in another medium. We can see this in this video. This is incident light. Some of its parts enters in another transparent medium and remaining part reflects back. When light ray incident obliquely means angle of incidence is neither 0 and nor it is 90. In other words, if light ray incident such that a light incident ray does not parallel to interface nor it is perpendicular to interface, then when it travel from one medium to another medium, its direction of propagation change. This change in direction of propagation is called refraction. From this video it is clear, this is incident ray, incident at this point. This is called refracted ray. A ray which enters in another transparent medium is called refracted ray, and this ray which bounces back is called reflected ray. Angle between incident ray and normal, this angle is called angle of incidence. Angle between refracted ray and normal, this angle is called angle of refraction. Now we learn this phenomenon of refraction word to word. When a beam of light incident on another transparent medium, this is incident ray, incident light, incident on another transparent medium. A part of light gets reflects back. This is reflected light into first medium, while the rest enters another. This is rest, remaining light that enters another medium. The direction of propagation of obliquely incident ray. This ray is incident obliquely. Obliquely incidence ray means angle of incidence theta 1 is in between 0 to 90, but it cannot 0 or 90. When it enters the other medium, it change its direction of propagation change at the interface of two medium. This is the interface that separate two medium. At the interface, the direction of propagation of incident light change. This phenomenon is called refraction of light. And now we learn laws of refraction. Snell experimentally obtained following laws of refraction. There are two laws of refraction. First law, the incident ray, the refracted ray, and the normal to the interface at the point of incidence all lie in same plane. This is incident ray, this is refracted ray, and normal to the surface on the point of incident. All these three, this one incident ray, this one refracted ray, and normal, all three lie in same plane. This is the first law of refraction. Second law, the ratio of sine of angle of incidence to the sine of angle of refraction is constant. Here sine of angle of incidence means it is sine theta 1. Angle of incidence is theta 1, and sine of angle of refraction, sine of angle of refraction means sine theta 2. Its ratio, the ratio of sine of angle of incidence to sine of angle of refraction is constant. This ratio is constant, and this constant is called refractive index of second medium with respect to first medium. This constant is called refractive index of second medium with respect to first medium. If we write N12 means refractive index of first medium with respect to second medium. If we write N32 means refractive index of third medium with respect to second medium. If we write N23, N23 means refractive index of second medium with respect to third medium. Similarly here N21 represent refractive index of medium 2 with respect to medium 1. Once again I repeat these laws. This first law is very simple. This incident ray, refracted ray and normal at the point of incident, all three lie in same plane. And second law, no need to cram this second law. इस second law को रट्टा मारने की कोई ज़रूरत नहीं है. Just remember this formula and write this formula in wordings. Sin theta 1. Sin theta 1 means sine of angle of incident. Sin theta 2, it means sine of angle of refraction. And sin theta 1 upon sin theta 2 means ratio of sine of angle of incidence to the sine of angle of refraction is constant, and this constant is refractive index of second medium with respect to the first medium. This is second law. We say this equation as equation number 1. This N21 depends on characteristic of the pair of media and wavelength of light, but it does not depend on angle of incidence. This ratio remains same. If we change angle of incidence theta 1, then angle of refraction theta 2 will also change. If we increase angle of incidence theta 1, then angle of refraction theta 2 will also increase. But this ratio sin theta 1 upon sin theta 2 always remains constant, and that is equals to N21. So this N21 does not depends on angle of incidence. Now we can write refractive index of medium 2 with respect to medium 1 as N2 upon N1, and we say this equation as equation 2. If we want to write refractive index of medium 3 with respect to 1, then N31 can be written as N3 upon N1. Similarly, N32, refractive index of 3 with respect to 2 can be written as N3 upon N2. Similarly here, refractive index of medium 2 with respect to 1, N21 can be written as N2 upon N1. Now if we use this second equation in equation 1, we get sin theta 1 upon sin theta 2 is equals to N2 upon N1. And if we rearrange terms, we get N1 sin theta 1 is equals to N2 sin theta 2. We say this equation as equation 3, and this equation 3 is known as equation of Snell's law. Is refractive index of medium 1 and N2 is refractive index of medium 2. Denser medium means optically denser medium. It means higher medium having higher refractive index. Optically rarer medium means a medium having a lower refractive index, and refractive index of any medium can be defined as speed of light in vacuum divided by speed of light in given medium. So from this equation it is clear N equal to C upon V, where C is speed of light in vacuum and V is speed of light in given medium. For optically denser medium, N is higher, so V is lower. That means speed of light in optical denser medium is less, and for rarer medium N is less, so V is high. So in optically rarer medium speed of light is more. Now we see what happens when light enter from optically rarer medium to denser medium, and what happens when optically denser medium to rarer medium. Then after we will learn why this happen. Here light enter from optically rarer medium to optically denser medium. From this it is clear, when light enter from optically rarer medium to denser medium, it bend towards normal. This is actual path. This is actual path of light ray, but in denser medium it move in this direction. That means it bend towards normal. Similarly, when light enter from optically denser medium to optically rarer medium, it bends away from normal. From this diagram it is clear, this is actual path. This is actual path of incident ray, but After refraction it bend away from normal. Now we learn this thing from this equation. We say this medium 1, so its refractive index n1, and this is medium 2, so its refractive index n2. This angle is theta 1 and this angle is theta 2. So as this medium is a rarer medium, value of n1 is less than value of n2. So first case, if value of n2 is greater than value of n1, that means if light ray incident from optically a rarer medium to denser medium, that means in this equation, as the value of n2 is more than the value of n1, so to become this equation equal, means to become left hand side and right hand side equal, as this term on right hand side is higher, so this second term on right hand side becomes less than this term of left hand side. That means sin theta 2 is less than sin theta 1, and hence theta 2 is less than theta 1. As theta 2 is less than theta 1, that means angle of refraction is less than angle of incidence, so light ray bend towards normal when it enter from optically rarer medium to denser medium. Similarly, in this case, suppose refractive index of this medium is n1 and refractive index of this medium is n2. This is angle of incidence theta 1 and this is angle of refraction theta 2. Here n2 is less than n1. This value n2, it is rarer medium, so n2 is less than n1. This value is less and this value is higher. As n2 is less than n1, that means this value of this term n1 is less than n1, so sin theta 2 will become greater than sin theta 1. Sin theta 1, therefore theta 2 will become greater than theta 1. As this theta 2 is greater than theta 1, that means this refracted ray bend away from normal. Thank you.